All right, example one using the comparison test. I think this is super important. So first, I'm given a series, of course, and I'm asked to tell whether it converges or diverges. Now, I told you in the last video, you're going to have to come up with another series that is either bigger or smaller, and you don't know which one. So this is what I do. I list out some possible things I can compare this to. And this part is just based on experience. You'll get more and more comfortable with this as you do more and more problems. But really, I'm taking this part, and I'm just going to slightly change things. I'm going to try and change the minimal amount. And something that I can easily change is, well, I'm going to compare to, and I'm going to just think of some options. I can only think of one thing to do right now, but I will compare to, I'll do it in a different color. So my first thought is maybe, okay, instead of n cubed, I can compare this to 1 over n to the 5th plus 4n plus 1. Something that I found very useful is if I'm changing stuff, either change it in the top and nothing changes in the bottom, or change it in the bottom and nothing changes in the top. Actually, this is not my first thought. I'm going to move this actually. So that's one option. I just changed the top. My first actual thought, because I've been doing this before, or I've done this before, was to just change the bottom. N to the 3rd over, and I'm just going to take this part out. N to the 5th. Now that's a very simple sequence that I can look at. So that was my first thought. That one is my second thought. So, and I'll hopefully compare both of them. But remember, I'm just slightly changing either the top or the bottom and seeing if it becomes an easier sequence to look at. So I'm going to simplify this now. And this becomes, what, 1 over n squared. And if I look at a series involving that, this is a p series, where p is greater than 1, so this must converge. Great. And then I'm going to look at this. Maybe I could factor. Maybe it's a telescoping series. Nth term, no, that doesn't help. I suppose, since we're only adding positive numbers, we could do the integral test on this. But that seems like a lot of work, and I already have a different idea. Integral test is always a lot of work. So I'm going to just try and see what happens with this sequence, and I'll compare it. So now that I have chosen something to compare to this, I need to see which one is the bigger one, which one is the smaller one. So this is important to pay attention to and to understand. So I'm going to write down both of these sequences, n cubed over n to the 5th plus 4n plus 1. And I'm comparing that to this, which is the same thing as that. So I would compare it to 1 over n squared. So that's what I'm comparing it to. Now, what was the difference? Actually, I'm going to write n cubed over n to the 5th. That way it's easier to look at and see what's different. But it's the same thing as 1 over n squared. Okay, so if I have two fractions, actually, remember, n is 1 and greater, so n is always positive. And the only difference between these two fractions is that this is gone in the second one, right? That's gone. And this is always a positive number. So I'm taking n to the 5th and I'm adding something to it, adding something positive to it. So if I take away this, then when I compare these two denominators, which one's smaller? I took away a positive number from here and wrote this down. So, of course, this one is definitely smaller than this one. Hopefully we understand that. Rewatch that part. It's super crucial to understand. If you don't understand it, rewatch it. So, if this denominator is smaller than this one, which fraction is smaller? Well, if this denominator is smaller than this, and the numerators are the same, well, that means if I make the denominator small, the whole entire fraction gets large. So this must be larger than this. Must be. So now I've figured it out. This one's my bigger series. And it converges. Great. Remember, the big one, if the big one converges, then the small one, no matter what, always has to converge. And we just need to make sure that this one, or the one on the top, is always greater than 0, but of course it is, because you're only plugging in positive numbers. We don't have any negatives there. So, great. That's the comparison test is done. Because this converges, this must converge. And that's because this one was the bigger one. If I found out that it was like that, and this converged, I wouldn't know anything. Because if I said, okay, suppose that one's going to be blue. Actually, I'll make it red. If that one converged, and we know that this one's bigger than that, that will be in blue. I don't know whether it converges or not. This one stops, but this one could either diverge or it could converge. I don't know. It's inconclusive. So luckily, I didn't figure that part out. I mean, I knew that it was that. So hopefully that makes sense. And I'm going to write down what my answer would look like. So this series converges by comparison with that, which is a p-series. And that p-series converges. So there you have it. Let's do another example.